So now let us welcome our first speaker, Professor Congcong. Professor Sun is an assistant professor and PhD supervisor at Wageningen University. She is also the head of the ICI AI Agri-Food AI Lab. Her research focused on intelligent control, agricultural robots, and autonomous systems. Today, she will present a talk, Intelligent Control and Robotics in Agricultural Production. Please enjoy me in welcome Professor Sun.
Good evening, everyone. First of all, thank you for the chair, Professor Lee, and also other organizers of this forum. I feel very honored and also pleased to join and to share part of my research. And I am Congcong Sun. I am an assistant professor from Wageningen University, and my research is focusing on intelligent control and robotics for agriculture production. And as we know that agriculture is important sector, but now is facing a lot of challenges like the growing population and the changing climate, and also the lack of laborers. And recently, the company Kubota released a video about future agriculture, and I will play a part of it so we can see how the future agriculture will look like. So from this short video, we can summarize that in order to tackle all the challenges in future, the agriculture needs to be optimal, which means we want to use less resource, less energy cost to improve, to produce maximal food. And at the same time, we want to make the production autonomous in order to save some human labors. And we also want to make the agriculture sustainable. That means while we are producing food, we also need to take care of the environment and the resource usage, etc. And also the future agriculture will be cooperative, which means we will use robotic AI, but that will also coexist with human, with the crop, with animal. So they will coexist in the same ecosystem and to cooperate with each other. And in this context, we also want to achieve safe production, which means, well, the machines also need to take care of benefit and welfare of animal and crops. And so to achieve all these objectives, control is an important techniques or concept. So control, I believe most of us know what is control. It's mainly about from observe our system, we will compute or learn some optimal control actions to achieve our control objective. So this part we call it the control function. And next, I will share some of our research topics and to explain the role of control and also robotic in agriculture production. And one important use case is we use control like reinforcement learning or model-based control to achieve optimal production of controlled agriculture like greenhouse, vertical farm, and where we can provide the best growing environment like the temperature, humidity, CO2 injection for the crop in order to minimize the cost, the energy, and maximize the yield. So in general, using optimal control algorithm, we can increase from 10 to 30% yield in average, and we can also reduce from 15 to 40% energy usage and also CO2 cost. And another use case is we also use control for like animal house, poultry house, pig house, dairy house, during the production. Like using reinforcement learning, we can optimally and autonomously control the indoor climate, the temperature, humidity, etc., to make the animal feel comfortable while maximizing their production. And we also can use control to reduce the ammonia release from the house into the environment, because as we know that the ammonia and the methane, this kind of greenhouse gas emission, the livestock industry take 1/3 of this release. So it's very important to reduce the emission, like using the control techniques. And we also we are also trying to integrate the like the animal production and the greenhouse production together with energy, with water sector, in order to reuse the waste and also minimize the impact and to achieve transaction of the agriculture production. And another important application is for the robotic. And here we mainly talk about how to plan the working parts and how to control the machines, the vehicles, in order to keep them working optimally and also safely. For example, nowadays in the arable farm, we're trying to use multi-engine, multiple vehicles, smaller vehicles to achieve the operation, because the smaller machine can reduce the soil compaction to keep the production more sustainable. And in this way, we really need to plan the working parts of each machine to make them working cooperatively and also trying to keep the safety distance with each other. And we also, another use case is we use, in the animal house, we use manual cleaning robot to clean the floors. And in this way, we can keep the environment for the animals comfortable, reduce their disease, and also reduce the emission to the environment. And in this project, we are trying to first build an environment where the users can design the layout of their animal house, of their barn, and also select numbers of the animals, and also numbers of cleaning robots. and select the algorithm, then you can plan the working path for each of the robot, and also trying to control the working path in order to optimize the cleaning task, and also keeping a safety for the animals. So here is the tools we developed, and using this tool, you can know which algorithm will have which kind of performance after the simulation. And at the same time, we're also trying, as I said, we want to keep safe control of the manual cleaning robot. So in this way, when even we plan the cleaning path for the robot, when it meets a group of animals, it will trying to re-navigate the path, and in order to not affect the daily life of the animals. So in this work, we most of work we are using reinforcement learning for the planning and for the control, and we can showcase some preliminary results. For example, when the robot is crowded by a group of cows, and using our planning algorithms, we can re-navigate a new path without affecting any of the cows and continue the cleaning task. And the work is first finished in simulation, and after that we will move them to application. And the work is, in general, is collaborated with some robot company like Lely. And besides, we are also working for sustainable production, and this is one ongoing project about developing biodegradable soil sensors for future agriculture, because if we want to use to achieve digital or intelligent agriculture, we will need a lot of sensors, and that will be a kind of electronic pollution. So we're trying to produce some sensors which can be biodegradable, and after a few years it will digest by the soil. And I can show you also a short video about what we want to do in this project.
Tomorrow's agriculture is highly technical, using state-of-the-art techniques that make food production sustainable. It is necessary in a world with challenges like climate change, soil degradation, and resource depletion. We already use sensors to measure the water and nutrient content in the soil, and to plan harvests in such a way that the soil is optimally used. Existing sensors are difficult to recycle, and they contain substances that are harmful for the soil and for humans. We need to make sure that we can use the sensors based on a biodegradable concept and eliminate the e-waste. Green Sensors proposes a new approach. It aims to develop soil sensing technology that is fully biodegradable and not harmful to nature. There is no need to recover and recycle the sensors. You can just leave them in the ground. We envision the distribution of a dense sensor network to get better insight into the variation in the field. Insight into this variation will allow better local management. Yet dense sensor networks are easily distributed, but less easily recollected from the field. Here is where the biodegradable sensor networks come in. On top of that, we want to start a green Internet of Things movement for agriculture, acquiring targeted information from data we can use to determine the smartest way of farming. This optimizes harvests using the right dosages of water and fertilizer and proper timing. The green sensors already fit into the cycle of nature. They will be made of natural materials, such as wood, natural polymers, and wax. They do their job for a certain period and then degrade fully over time. In the future, data plays a vital role in sustainable agriculture. This will result in better crops, better usage of soil, and higher yields, using less resources and without polluting. Green sensors is the future of sensing in agriculture, and it will be the preferred technology, both in costs and in terms of sustainability. Do you want to work on innovation and contribute to the future of agriculture? Go to 40u.nl/green sensors.
Yeah, that is all for my presentation. It's relatively short, but I'm open for questions from you. Thank you again for your time and attention.